Okay, thanks a lot. It's very unpleasant to be here as the last one just before we go for lunch. So I will try to do it quick because I know where everybody wants to be right now. Just short on we have some pamphlets on the tables over there where you can see a bit more about a concept about our decommissioning of wind turbines. Just short about HG Hansen Recycling. We are established in 1829. Since 1888, we have been handling scrap as well because we were starting as a small shop in Odense. We are handling almost 1 million tons of scrap, so that's ferrous and non-ferrous metals every year. Circularity is a vital part of our DNA, and we are a full service provider in decommissioning of land-based wind turbines. We have a team of specialists within their own specific field, so that's ferrous, non-ferrous, cables, and concrete. That's what we use when we look at the decommissioning. Also, we are very focused on traceability and transparency to customers of all the products through the entire value chain, and that means we always deliver a KSM report when we are doing decommissioning of any kind of products. Looking at the wind turbines, we have as I mentioned, a full service provider. That means we take everything from the foundations to the towers, nacelle, covers, everything, the blades and everything we have established routes for. The demolition group, which is in charge of doing decommissioning of wind turbines as well. We have about approximately between 100 and 200 projects per year. Obviously, some are big, some are small. But we do primarily do demolition or scrapping of steel constructions. When we look at the wind turbines, some of the projects that we have done is recently is the Østerild Test Center for Large Wind Turbines, where we took down a GE wind turbine, which was basically an offshore test wind turbine, but we did decommissioning of that at Østerild, taking up a huge foundation as well. There was a monopile and everything was on top of that as well, so to simulate offshore. So it's been there for 5 years, and we took that down this spring. DecomBlades, I'm just going to skip that because we're short on time and probably know what it's all about. But when we look at the DecomBlades project that we are part of, we work with a value chain that looks like this. And what is illustrated is the link between the different stages. We have more pre-processing options, so that's the pre-processing is what is happening on site. Depending on what is chosen there can be more options for the mechanical grinding, and again, this will influence the potential off-takers of the product that comes out of this mechanical grinding. But it also goes the other way. Demands from the off-takers can influence the previous stages in the value chain. As with other materials we are constantly on the lookout for new partners and new ways to recycle or reuse the products that we handle. So some of the applications that we have is pyrolysis and concrete, which is also part of the project through McKean and FL Smith. But noise screens and incineration and Holcim is obviously also some of the more established routes that are there today. But there are some challenges, and one of the challenges is just the sheer size of the wind turbines. This is a test blade that is being removed. It's 4.2 meters root diameter, and obviously that creates some challenges both on the pre-processing, so that's what's going on site, and also the transportation, because we need to cut it into pieces or find a on-site mechanical grinding solution, which can be also very tough when we're looking at the size that we are dealing with. So challenges basically is there's no standards. Also, not all applications can use all kinds of chemical compositions, as mentioned previously. For instance, chlorine is a factor when we look at the material used as a fuel. That creates some problems. There are a lot of wind turbines that are more than 25 years old, alone in Denmark, but they come in all shapes and sizes. We don't know when they will be taken down. There's a lot of macroeconomical aspects as well. What we've seen is a bit of a stop in decommissioning due to the war in Ukraine, because energy prices suddenly rise. So not like half a year ago, wind turbine owners maybe got 10 euro per kilowatt hour, and today maybe they get 70 euro per kilowatt hour. So suddenly it's a good business to leave the wind turbines on land, and that also creates some issues when you're looking at having, as mentioned, Stina we would also like, when you have a production facility, you would like a steady flow of materials. So when you suddenly have a stop and you don't know if you get any material for 3, 4, 5, maybe 6 months, that can also create a problem. We don't know what the composition you will get, the flow of materials. Do we get all the blades that are available? During the last 5 years, an estimated amount of material taken down is between 450 to 800 tons of blade material every year. But it's unknown actually what has happened to this material in the afterlife. Have they been scrapped, used for spare parts, established elsewhere? For instance, we know that some have gone to Finland, some have gone to Africa, Poland, other countries. So it's still uncertain what basically what the full potential of this is. What are the requirements from the off-takers is also a big issue. And then there's the LCA and carbon footprints in the different scenarios. So that's what we definitely SDU is working on, whether pyrolysis is the best solution. And then there's also a lot about the pricing of what's going on. So, as I mentioned before, we look at the waste hierarchy is basically part of our DNA. We do aim high. We want to go high as possible, but right now, landfill and there's some few options that's left in the bottom, and we're really looking at companies or 4 companies, partners that can take us higher in the waste hierarchy, where we could do some reuse or do some prevention of it. And there's a lot of service providers out there that are working on this, and we do believe also believe it or not, in the waste industry, that wind turbines should be out there as long as possible. But when we look at repowering, that will also create another problem, because we'll get a lot more blade material, and there's a reason why it's taken down. It's because there are blades that are more efficient and makes the wind turbines live longer, and what will happen to all those blades that come down will need to be handled as well. So my final slide is actually the cost that we're working with as well. The easy thing and the most cost effective for those getting rid of the wind turbines is actually the landfill, because there's a short pre-processing, there's a transport, and there's a landfill. But landfill, for instance, the industry is very keen on not being an option. As Ørsted has mentioned, in 2025 they will not accept landfill. But that will mean that we will need to do pre-processing, transport, then there will be more processing, more transport, and then will need to be used in some sort of application. And obviously, when you add more steps to handling a wind turbine blade, you will see the price going up, because all those steps require will add extra costs to that. And that will, on short term anyway, increase it, also because there's not a pull in the market right now, it's a push. So we want to get rid of the material, and there's not a lot of off-takers. So hopefully on a longer term, we will see a decrease in the pricing, where there will be a pull for this material. We see that in other markets also, that once you get established routes, more people find ways for using the materials, and then you will see a pull for the different materials. Very quick presentation, short. I hope that's okay.
Well, so let's give him a hand.